Hello everyone, let's do this is a class note 2.1 about transformation, especially for absolute value function. Let's look at the absolute value function. A parent function we are going to use absolute will be, this is a parent function, okay? And then we are going to say this one is, we can also write it as that fx, okay? All right. First one, vertical translation. Vertical translation is either go up or go down. So this one is a function notation. We can say new function fx was absolute value and then move k. For example, this one will be new function that transform from the f of x will be, oops, that's wrong, that's a horizontal, vertical will be 3. That means vertical translation up 3. New function that is from absolute value move translate down 3. Simple, huh? Next one, horizontal translation. Horizontal translation means, look, I always said it, this one is group X is group with H, so it is a horizontal move, horizontal translation, side by side. So new function that is translate, just like I said, this negative is a built-in, okay? So new function, let's look at the example. New function is moved to the right, okay? So new absolute value function moved to the left. Also this one is H, right? And that means horizontal translation right 3. Right 3. This one we can say negative is always there, right? This minus, I'm sorry, minus is always there. So new function x double negative positive move to the left. Negative right here is move to the negative left side. Horizontal translation left 3. My computer is getting hot, so it's running fan. All right, let's do the vertical stretch and compression. Pay attention. A is multiply. 3 is multiply to original function. So new function is 8 times 3. If we, for example, if it's a 3, new function is vertically stretched 3 times. So this one, verbal description is vertical stretch by 3 times, 3 times, 3 times, 3 times is this factor, multiplying, right? By a factor of 3. Factor represent multiplication, right? And this new function is 1/3 times of parent function. This is called vertical compression by a factor of 1/3. So if I draw a very rough graph, the parent function was this way, and 3 times is stretched by vertically. How can we tell from the table, right? If x is 1, y is a 3, because this one, this one is a 3 times y got stretched. But parent function, this is a g over x. And parent function, 1, x and y, 1 is 1. So it should be 1 is 1, but now 1 is 1, but it's got 3 times stretch. I hope this makes sense to you. Next one, horizontal stretch. Let's look at the horizontal stretch. I'm gonna erase a little bit. There is a typo right here. If instead of 1/3, it should be B. Oh my goodness. Let's erase it. Instead of 1/3, this is typo, B. So new function is 1/3 of x. So b is a 3, right? So I'm doing the same mistake here. 1 over b. So new function, for example, is 1/3 of x, which means that b is a 3. B is a denominator, right? So what it means that this is a horizontal compression by a factor of b is a 3. In this one example, if you see 3 times x inside the parentheses, that's a horizontal. The new function will be 3 times x. Oops. So which means horizontal stretch by factor of 1/3. So b is, in this case, b is 1/3. So it's a reciprocal. Simply, when it comes to horizontal, you can think as like a reciprocal number that you are going to use, because this is like a 1 over b and divided by 3, right? So remember what you learned during the class time. And reflection, this one is reflect over or across, we can say across x-axis. And this one will be reflect over y-axis. Normally we use this graph. And this one we can do, it will be also, this is what a, right? So x and y. The parent functions are like this. Okay, that's it.